Okay, so let's get to building. We've got our battery. And we're going to use a 9-volt battery for our little night light. And I'm going to put the positive in F1. Come on, this is a brand new breadboard. There we go. That's an F1, and I'm going to put negative into the negative rail. And I'm disconnecting the battery, by the way, because you shouldn't have power to your circuit until it's completely built. So here we go. Now, if we look at our circuit, the next thing is our power diode. So my power diode now is going to go from, we'll just put it in H1 over to the positive rail. Now anything we plug into that positive rail is now protected by our protection diode. So this positive rail right here. Now the next thing we want is our NPN. So facing us, once again, it's Enjoy Baked Cookies. And because this is an NPN, let's see, put that down. So facing us, I don't know if you could read the... So we have our NPN, and it's a 3904, I believe, is on there. Yep, 3904. And so with the flat portion facing us, it's EBC, and we want the C to be, so we want to go from C to E for the power on this. So what we're going to do on our breadboard is we want to do that little waterfall again, where we have our C is actually in J8, our B is in J9, and our E is in J10. So there it goes. It's facing the power rail. So if it was facing us, it would be EBC. Now it's facing the power rail, so that C is near the diode here. So we got C, B, and then E. And just for you guys, it's emitter, base, and collector. That's what the EBC stands for, emitter, base, and collector. So now we have that. So what we need to do is we need to connect the C to power. So let's break out our lovely connector wires here. Got a brand new pack of them. Now, I have some existing ones already unpacked. But I want to use certain colors for this, just so it's easier for you guys to understand. We're going to take a small red, and we're going to go from the power rail over to I8, which is the C on that NPN. Now we want a resistor, which is our 22K resistor. Which is this guy. That's our 22K resistor. we want him on the B, which is our middle pin. So we're going to go from B, which is, we're going to put it in I9. And actually I put the power in I8. I8 and I9. Now we're going to bring this resistor down. And we're going to put it in I15. Like so. So we go from I9 to I15. Okay, now we want to take our trim pot, and we want that to go from power, our potentiometer. So I'm going to plug that into the power rail. Solid cord wire, it's a little easier to push in. And that's going to go to the other end of our 22K resistor. So I'm going to put that in H15. So now we've got our trim pot, and we're going from the power rail to H15, which connects us to the other end of that 22K resistor. Now, well, I guess we should have done this first. See, that's what I get for not having these scripted. We need our 1 million ohms dark LDR, light dependent resistor. So, what we're going to do is, we're going to take this one first. And we're going to hook it up to our multimeter. And we have some light here, and we can see it's 4K ohms. Now, if I completely shut it off into the dark, it goes up to approximately 73K ohms. So that's not good. We can really, if I put my flashlight on this baby, like we did before, I can really bring it down to, see, there's 200 ohms, 150 ohms around there. Okay, so let's see if we can get a little closer than that. So we're going to take this big bad boy here. We're going to try him next. He's a lot bigger than the other one. Yeah, I just bought a pack of LDRs. It was like a pack of 100. And with light, this guy is 3K. Let's seal him off from the light. See, just like that. Seal him off from the light. And we've got 24,000 ohms. So that's not even as good as the last one. Let's put that aside. Now I'm going to take one of these really tiny little ones here. And with light, wow, that's 10K with light. Let's see what happens if I really put some on it. We've got 150 ohms. Okay, so with light, this guy is 15K, normal lighting. Let's seal him off and see what we get. Now this guy's 200,000 ohms, a little under that, depending on how much dark I can get him. Let's call it 200,000 ohms. And we got one more to try, actually two more to try here. I think this one is identical to the last one we tried. So we'll just put him on and just put him in the dark. Nope, and although he looked identical, in the dark he's only 49,000 ohms. So he looked identical. Can't judge an LDR by its cover. Okay, and this last one. Put him in the dark. Ah, this is closer. This is 500,000 ohms. 500,000. I think this is the guy that we're going to use. 500,000 should do it. Okay, so let's take these guys and put them in our little parts tray to keep them out of the way. Okay, so according to our schematic, which you should have printed out from the lecture portion of this, we are now going, and remember, there's no polarity on these, so it doesn't matter which end you put in which side. We're going to go from C on the potentiometer, which is at the end of that 22K resistor. So one end of our LDR is going to go into, we're going to do F15. Now, if I wanted to, I could put this in another one here and then bring it over to ground, but I think this will reach all the way over to the ground. So that reaches all the way over to ground, so I don't have to put another wire in there and make it more confusing. So our circuit's almost done. We just got to go now from the emitter to the lights. Okay, so now we want our LEDs. And let's jump into the parts bin. Grab some LEDs. Now, earlier I was using, you notice throughout these tutorials I've been using 470 ohms resistors for these LEDs. You might want to use something a little higher for these LEDs, just because the LEDs I'm using are the super bright 20 milliamp LEDs. I know when we measured the current it was 11 or 12 milliamps of current. But these guys could take a lot more current than others. And with 9 volts, I've actually burnt out a couple of these guys. So, well, they could have just been bad. But you may want to use something a little stronger or use 2 LEDs. We're actually going to use 1 LED in this circuit for our night light. And, I'm sorry, we're going to put in our 470 ohms resistor. Now our 470 ohms resistor is going from the E, or the emitter, on our PNP. And the emitter is in J10. So we're actually going to go I10 over to E10, across to the other side of the board. So you should be able to see that. I10 to E10. And then we're going to take our LED and we're going to go from A10. Remember, now we're dealing with polarity again. So the longer end needs to go on the positive side, the shorter end goes towards the negative. So we're actually going to plug the shorter end into the negative rail, as well as, I don't know if you could see it, but there's a flat end on the shorter side. See when I rotate that? There's a little flat end. You could feel it on the shorter side. So we're going to go from A10 to the ground. And from A10 to ground. Remember, the longer end is in A10, the shorter end is in the ground. Okay. We have built our little nightlight circuit. Let me shut off this. Okay. So now what I'm going to do is I'm going to connect the power. And when I connect the power, actually the light came on when I connected the power. If you remember, we only used 500,000 ohms when the circuit called for 1,000,000 ohms LDR. So it's a little more light sensitive than before. So now I started with the highest range. Actually, let's zoom in on this. Okay, the best laid plans of mice and men. Now you might be able to see that that LED is just on just a little. If I give it another light source, it will stay off. So what happens now is when I turn the potentiometer, the light almost immediately comes on. I think I'm going to recreate this circuit later on and do a printout. I think I need a printout to show you what's going on as we're doing it. Actually, hopefully I can add that in there. So basically, as soon as I get rid of almost any light, this comes on because of this LDR. Now what could we do to correct this? Well, we could have a higher trim pot. Instead of 100K, we could have 200K or a 500K trim pot that allows less electricity to come through. See, what's happening is the electricity is coming through and the LDR isn't allowing enough to go out. So let's actually change the LDR and see what happens. But let's take one out and see what happens. You notice as soon as I take out an LDR, that light comes on strong. Of course, you should unplug the power before you do this, but I'm a little reckless, I guess you'd say. So, because there's no path to ground. So let's put in our LDR. Come on, new breadboard. There we go. And then over this side. So now with our new LDR in there, it's not coming on at all. So this LDR is actually better. Let's I don't know why that's not focusing well. Let's zoom out just a little. Okay, so let's measure this LDR. Let's see what we got here. This is why most people script these things out, so they don't embarrass themselves. I myself don't care about being embarrassed. Switch over to ohms on our multimeter, and we can see with light, it's about 4K, and without light, we've got 44K ohms. So what does that mean? So let me put him back into our circuit. And remember, you guys disconnect your batteries at home. Do as I say, not as I do. Just kidding. Feel free to destroy some of your stuff. Okay, so basically right now we could actually build this circuit and we could adjust the trim pot to have the light go off at the desired lighting. Or if we didn't want to waste a trim pot on this and we knew that this was always going to require to be on in the same amount of light, then what we could do is let's assume that this is it. In this light we want it off, and this light we want it on. So what we could then do, now if you remember, our potentiometer is going from power to the other end of the 22K resistor. So that if I unplug this, so I unplug this right now, potentiometer. Come on, focus. So I've unplugged our potentiometer, and now I'm going to hook it up to our multimeter to measure what the exact ohms reading is on this right now. And it is 13.02K, 13K. So if I take a resistor close to that 13K, or say a little above it, it will function just as if this is functioning now. Now you can't adjust your night light anymore. It will always come on and go off at that particular amount of light. If we put that in there, if we replace the potentiometer, let me zoom out. Sorry for the shoddy camera work, guys. So basically, if we went from power to this 22K resistor, there's no connection. This light won't come on no matter what I do now, because the potentiometer was supplying the electricity through this resistor to the base, and that's what would turn our circuit on. So, do I have a resistor? Let's see what this guy is. No, so we know around 13K. Let's see how lucky we get. Of course, I can see right on here it's 2.2 million. 2.1 million. Let's see what we can get out of here. Give me a second. Let me just run over to my parts. See what we got close. A nice 10K resistor. Okay, guys. We've got 10K resistors. We've got 10K, 22K, and 5.5K. So let's grab a 10K. Let's see what we got here. These are actually blue, and it's harder to read the colors on the blue. On the blue backing. 10K. And the other ones are 22. See what I mean about those colors, reading them on the blue background? It's a little more difficult. Okay, so right now I'm going to take this 10K resistor, and I'm going to go from power to, I don't know what we were in before, but I'm going to put it in H15. I could put it in anywhere in 15. So there we go, H15. And with the light we have now, it's off, and when I cover it up, it comes on. See, look at that. So what you could do is you can take your potentiometer, you know, because this is going to be your first basic circuit. Who knows, you might even cannibalize this later on. We're actually going to solder this together, and I'm going to show you a neat way to do that. So this is a 10K ohms resistor. Now, if I wanted to get closer, what could I do? Since I have a 10K and I have a 22K, how could I get closer to what this was? And let's take a peek at what this was again. Okay, this was 13K. So what could I do? Well, I could put some, if I wanted it to get it closer, I could put some another resistor in series with this one, right? Not parallel, in series. So I could use a 2.2K. Would that give me 12.2K? Let's actually do that, because I know, now that I've broken out my parts bin over there, I can quickly find a 2.2K. I got a 2.7K too, or a 3.8K. Let's go with the 2.2K though. Oh, this is a big bad boy. This is a... this guy's a half-watt resistor. That's another reason you might want to put resistors in parallel. If you're dealing with quarter-watt resistors and you need a, you need a half-watt. So let me verify. I always verify these parts. These are more expensive resistors I got a long time ago. And it's funny because I use all my other cheap resistors in projects, and I'm saving these ones for some super project that I need extreme accuracy. This is 2.2K. So now we have a 10K resistor in there. And it works pretty good for this light. But, so now I'm going to take this 10K resistor, and I'm going to go from the power rail, and I'm going to go from the power rail to I-21. From the power rail to I-21. Then I'm going to go G21 to G15. G21 to G15. So now I've put these, I put a 2.2K and a 10K in series. So in theory right now, I should have 12.2K. So when I cover this up, so now he's not as sensitive as he was before. I mean, I know this looks the same to you guys, and the only reason I put that in there, that actually means there's less power coming from here to B, which means he requires it to be darker for this light to come on. So now he needs it a little darker. So, you know, people use resistors in series all the time, in parallel too, but in series I found that I use resistors in series more than resistors in parallel. And that's a nightlight. Okay, what are we doing now? Oh, I know. Now, what happens when we want to actually create a circuit? And we don't want to create a printed circuit board. We're not going to create 50 million of these. We're creating one for, you know, Uncle Tommy because he's afraid of the dark. And he wants an automatic nightlight. So we're creating one for him. Well, you're going to see here? I got a few of them, don't I? These are pretty much breadboards. What you see, they're a printed circuit board that's like a breadboard. Now, of course, this would be a larger circuit. Let's get one that we're going to use on this. We're going to use one of these two. This one here actually breaks. And it's actually 2 for a really small circuit. And we could get away with this small one, I think. But this one is more in the shape of a breadboard. And what we can do is we can connect these things together. We can, you know, on this side is where you put your circuits in, and then you solder them on the copper side to the connectors. And this is, you know, it's like having a little printed circuit board. Now, before they came out with these, what happened was there was no copper on these. And you'd put your circuits into these little holes, and then you would tie them together with wires and solder the wires, and it created a big mess. But someone figured out if the breadboards are so great, what if we made one printed circuit boards like breadboards? And you can get big, elaborate ones like I have. One of the things I'm doing is I'm creating an LED TV. Now, I know what you're thinking. No, I'm not creating an LED LCD TV, or I'm not creating, you know, one of these 1080p televisions. What I'm doing is I'm taking a series of integrated circuits to control a whole bunch of LEDs. And so all these LEDs, it's going to be like it's not going to be as big as a Vegas one, but this is what they do for Vegas, for those giant TVs. And I'm going to create one that can print pictures on it. I'm going to use some Perlin noise to have a fly around on it. It's actually going to be pretty neat, and if you guys are interested, I'll actually make it one of the projects we can work on. Now the problem is, I buy these at You Do It Electronics, which is in Needham, Massachusetts. And I gotta find these online for you guys so you can purchase them somewhere. Like I said, they're very neat, and I think we're gonna try to use, I'll count all my connections and we'll try to use one of these. And we're gonna do a soldering lesson. And we're gonna use lead-free solder, non-lead. I've heard non-lead, lead-free. Most people use lead-free. Lead-free solder, especially if you're new to electronics. It's more difficult to work with, but it's safer. You're not breathing in all those lead vapors, especially if you're young. If you're old like me, who knows whether it makes a difference or not. But I always use the lead-free solder, and if you start using it now, you will get used to it, and you'll never have to use lead solder. So in our soldering tutorial, we're going to mis-solder a component so we can unsolder it. We'll use a solder extractor. We'll also use some solder wick to get rid of it. And there's ways to use non-lead solder, and it's almost, I don't want to say counterintuitive, but it's different than the way most people teach how to use lead solder. And we're actually going to solder this. We're going to solder our little circuit here. And I'm going to spend some time breaking up this video and really edit it, because it needs to, I need to have the diagram in here and explain the flow of this to you guys. So you can see we can use these potentiometers to determine what kind of resistance we need for our circuit. You know, and I can even add some more. Let's actually, while we're here, let's add a bigger resistor. Let's add a 22K. I believe I already have one here. Let's see what this is. Burning low. Yep, 21.94, 22K. So now what I'm going to do is I am going to take out the 10K and the 2.2K. And now I'm going to put in a 22K. I'm going to put it from the power rail into G15. And wow, we're not getting much at all. We've really got to go dark now. See, what's happening is that this resistor, current flows through this resistor and then through this resistor to the base to provide the, to turn the NPN on. So when we increase the value of this resistor, we're letting less current flow through, which means we need more resistance going to ground to stop this current from flowing to ground to allow this light to come on. So just tapping it like this, it doesn't come on. But now it's really dark. And we're in a fairly light environment. I don't know how dark this is by putting my fingers over it. But what you could do is take the potentiometer and adjust it to wherever you want this night light, and then just put in a resistor. You know, unless you want an auto-adjusting night light, and then, you know, not only would we use one of these, but you can actually buy project cases. We can actually build it into a case and everything else. And we don't necessarily have to use a 9-volt battery. We could plug it in and have, you know, a 9-volt power supply for it. You know, depending on how elaborate you want it to get it. But this is the first circuit. Like I said, we're going to build many more and a bunch of electronics books. I'm going to list my favorites below, and I'll list some of my favorite electronics books below, and we're going to build projects out of them. Everything from electronic circuits for the Evil Genius to electronics projects for dummies to Make Electronics. There's a whole bunch of good books out there, and we'll build them together, and we'll experiment with them. Okay, let's go over some of these questions here. Matthew Peters we already addressed, and he was completely right. Imagination. I think I'm pronouncing that right. Sorry if I'm not. He wanted kits and stuff. He asked if I thought about building a website and having my own kits, and people could just buy the kit components from me, which is easier. I mean, I showed you guys where to get components real cheap. You know, you got to buy them separately, and yes, it could be a pain in the butt. It'd be nicer if you just had one kit thing to do. Maybe I will. Maybe I'll put the kit together for. I try to cater to my to the people with the least amount of money. You know, that's why this isn't a very expensive multimeter either. But that's why I use the very inexpensive multimeter. We're gonna do O-scopes and everything else, much more expensive multimeters. But I try to create these so that anybody can do it, whether you're a kid on an allowance or you're an adult with a fortune looking to spend. And if you're an adult with a fortune looking to spend, go to my website and donate. And I will guarantee I will keep making these. Okay, so where were we? Oh, so anyways, I will think about doing the kits. You know, at least maybe I'll have all the components and stuff you need so that, you know, you could do it. I don't know if I want to get into building kits of tools. It's what I really want to do is share the knowledge. We're actually learning together a lot of this stuff. Let me see what else we got. Jerry, you're killing me. You're killing me here, guy. Jerry is, I mentioned earlier, Jerry's got a receiver that he's trying to fix. And so he keeps blowing these PNPs and NPNs. And on the next tutorial, I'm actually going to show you how I looked up parts for him, because he wants to know how I did it too. I think I mentioned it in the comments. But he's having trouble because every time he replaces these components, they short out on him. So his problem is somewhere else. So what he has is, it sounds like, and this is just a guess, Jerry, since I don't have it in front of me. I mean, this is a fun project, and you're going to learn a lot by doing it. Be careful for the thermal paste. What I didn't mention earlier what thermal paste does. What thermal paste does is it creates, when you put this metal to metal, there's a lot of gaps in there that you don't see. The thermal paste creates a better, tighter bond. It creates a bond between the heat sink and whatever metal you're using to pull it away. So it creates a better bond between those two. Another NPN. Okay, so Jerry, you have something that's creating a short. There are many ways to find that. You know, maybe I can do a little tutorial eventually. It's more advanced than, first we want to test the circuits that we're building and then getting to something more advanced like a stereo receiver. I think we'll probably take one apart and use it for parts. Actually, I have a CD player we're going to take apart and use for parts before we actually fix something like that, that more advanced. There are books on testing just about everything, but it sounds like you have a short in there somewhere and it's blowing your components. So I would look for, just without seeing it myself and without knowing anything, maybe a crack in the board somewhere, a little piece of, I mean, it could be so many things. You know, a little piece of, I don't know how old this is, did it work for a long time? If it's new and it didn't work for a long time, they're in the manufacturer, there could have been, you know, a little piece of metal connecting, making a connection somewhere. It could be inside another component that's bad, that's creating the short. So there's many things, Jerry, and I'm sorry I can't help you more than that. I will continue to help you with your parts quest, though. Okay, Ivan and Thomas talked about a mix-up in the videos. What happened was, originally my tutorials, the way they went, it looked like there was something missing, and they were just mixed up the way that I had them. I have corrected that. And another Matt. It says microcontroller here for Matt. I don't know why I put that there. Larry, power across the switch. We already discussed that. You're testing the potential power across that switch when you turn it on. You can actually see what that's going to be, just like when we tested the battery. There's no switch here between these. I don't have a wire connecting these two, but yet if I put the leads on either side, even without the wire, I can see what my voltage across this is going to be. I think that's it. I don't know, Matt, why I mentioned a microcontroller, but we're going to get into the microcontroller and a lot of other stuff. I think that's about it. I think I covered about everything on this. Thank you for your patience with me. And as long as you guys keep watching them, I'll keep making them. We'll get more and more advanced. We're actually going to do this exact circuit on a microcontroller, on an Arduino, which is going to be very easy to do. We're gonna do it on Demuliv or an Uno, whatever the latest one is. I think if I got an Uno lying around, which is the latest, we'll do it on that. It's the same exact thing. It's a $20 to $30 Arduino microcontroller. But after that, the next tutorial, we're actually going to build our own microcontroller, and it's going to cost us less than $10. We're going to build our own Arduino, where you can take the chips on a breadboard, program them, and then put them into one of these and use it, so that you're paying, instead of, you're paying like $6, I think Adafruit has the chips with her own bootloader on them for like $6 a piece. So you're paying $6 and then a couple bucks for components, and then you're just putting that directly in here instead of using an Arduino development board. Or you could use the Arduino development board, take it out and put it in here. You still need the extra components. So we're going to go through all the pins, the microcontroller and all that other stuff.